This is Precalc, chapter 5.2. We're going to talk about trigonometric functions with real numbers. And so the first thing we're going to talk about again are the 6 trig functions. You guys know these from last year, I hope, or remember what they are. You know the big three. The big three are sine, cosine, and tangent of some value. Now they're using t, because we have not learned about theta yet, have we? Or maybe we have, but like we were making the connection back in 5.1, t was the reference number, and that reference number, without them telling you, we've decided that, hey, they're actually talking about radians. So when they use t here, they're actually using radians. And so they're saying let t be any real number, and let p of xy be the terminal point on the unit circle determined by t. So t is the angle we are going to use, or the number that will bring us to a point xy. Some of the things that you guys should remember is the fact that sine of t is always the y value. The sine is the y, right? The cosine is the x value in an ordered pair. And tangent, they say, is y over x. Well, if it's y over x and y is equal to sine, x is equal to cosine, that means that tangent is just the sine of t over cosine t. You guys remember that? It's one of the first kind of what we'll call trig identities, right, that you guys probably would have learned, where you can change tangent into sine over cosine. Then I like to call these the little three. The little three are the ones that you kind of learn secondary. You don't learn these first. But these are also called the what functions? Y, 1 over y, x, 1 over, not inverse, but reciprocal. These are the reciprocal functions, the reciprocal trig functions, because cosecant here is just 1 over y. And if y is equal to sine of t, that is just the 1 over sine of t. It's the reciprocal of sine. Now notice with tangent over here and cosecant, you can't be x equals 0 and you can't be y equals 0. Why is this? Because now you're talking about x being in the bottom of a fraction and y being in the bottom fraction. You can't divide by 0, right? Secant, the next one, secant of t is 1 over x, or 1 over cosine t. And cotangent is x over y. Now wait a minute. That's something different. That's not 1 over. That's now cosine t over sine t. But isn't that the same thing as 1 over tangent t? Why? That should be. Because all the rest of them, well, there's the reciprocal of sine, cosine. Why isn't this the reciprocal of tangent? Because it is. What's tangent again? It's sine over cosine. What do you do when you divide by a fraction? Multiply by the reciprocal, which leads us, boom, cosine over sine. That's why it works. We're going to evaluate trig functions now. I want to give you the reference number, or not the reference number, the number value t here, aka radian measure. I want you to find all 6 trig functions. Now, this is the way I like to do this, and it's not, the way. It's just a way. I like to start off by putting the big three, I call them. Sine, cosine, and tangent I like to find those first, because as soon as I can find these values, what do you think the little 3 are? It's just the reciprocal, guys. So I'm going to list them all. And then fill them in. Now, we have a couple options here. We can use our unit circle, at least the ones that you guys are starting to use as practice, or we use our reference triangles, because that's what we had to do in the last section. So at this point, the book doesn't even know you have a unit circle, but we do have one. You should have one actually in the packet that was done, right? So we go to pi over 3, which is a 60-degree angle, and if I was to draw this again, that would be pi over 6, pi over 3, and 90, which is 1, 2, square root of 3. What is the sine of pi over 3? Square root of 3 over 2. What is the cosine of pi over 3? 1/2 tangent of pi over 3. Square root of 3 over 1, or just square root of 3. There's a reason why, guys, I left it as square root of 3 over 1. Because you guys can reduce that anytime. It's because when I go take the reciprocal, if I don't have the 1 underneath, some of us get a little scared on what that is. So, take the reciprocal of square root of 3 over 2. 2 over square root of 3. Reciprocal of 2 over 1. Or 1 over 2, sorry. 2 over 1. And 1 over square root of 3. Now, would I expect on a quiz for you to reduce or simplify? Yes. Okay. Don't leave the square root of 3's in the bottom. I don't necessarily like that. Try the next one on your own. So, on this one, again, I'm going to write the big 3 and the little 3. I'll ask for some volunteers. Who can give us the big 3? We're going to write it down here. Carly's recording right now.
Okay, so draw, well, there can't be really a triangle drawn because it's not a triangle, so.
Right. This is one of the quadrantals, right?
Yeah.
So this is one you have to kind of know.
So the sine is 1, the cosine is 0, and there's no tangent. So there's just a little dash.
Okay. Why is there no tangent?
What would that require dividing by 0?
Yeah, requires us to divide by 0. You can't do that. There's actually a word for that. What would that be called? Undefined. So I'm just going to squeeze that into here. Undefined. Okay. Who has the little 3 for us then? We're recording. This is going to take a while. In one of my other classes, they said I've got 5 minutes of dead space in one of my classes. So, who's got it? Someone volunteer themselves, or volunteer someone next to them. Ashley volunteered herself. You guys all got lucky because she could have picked someone. Okay.
So the reciprocal of the sine would just be 1. And then the opposite, or yeah, the reciprocal of 0 would just be 0. And then instead of the sine over the cosine, you do the cosine over the sine, so that'd be 0 over 1, so that's 0 too.
Okay, Ashley, correct. Ooh, I don't know. We got some good things going on here. But, just like when I had square root of 3 over 1, a lot of times we just like that as, write that as square root of 3, right? Do you guys all agree that 0 would be divided by 1? It'd still be 0? So what's the reciprocal of 0 divided by 1? It would be undefined. Now, this is probably where, because this would be 1 over 0, which is undefined. I'm squeezing that in there. That says undefined. Because what we didn't do, especially for tangent, we got this one right. Ashley was good on the cotangent because she recognized that it should be cosine over sine, and the cosine is the 0, is because when we did tangent of pi over 2, we should have put 1 over 0 first to kind of show, hey, that's what the ratio is, and I cannot do that ratio, so therefore that's why it's undefined. Make sense? Get the big 3, and the little 3 follow suit. Not too bad. This one's just an informational slide about the domains of trig functions. As you can see, the sine and cosine are all values. Why? Because they are periodic, and they just go from positive 1 to negative 1 and keep repeating over and over and over, right? You guys should have seen that potentially on that simulator that we were using, that as you rolled around the circle, it just went up and then back down and up and then back down, right? So that's all real numbers. I can put any kind of angle I want in there. Tangent and secant, cotangent and cosecant all have issues. I think when you guys were playing around with the simulator, you would have noticed, I'm trying to think which way they went. I do believe they went this way.
Yep.
You saw graphs that end up looking like that, and that was for tangent. But why? Why would that happen? Because technically, what is tangent again? What is secant? What's on the bottom? They all have a 1 over cosine, right? Cosine's on the bottom. It's either 1 over cosine, sine over cosine. Going to the bottom, it's the sine on the bottom. And so, where do these have their values equal 0? End up being vertical asymptotes, yes? So, when does that happen? It happens here, at pi over 2, plus pi n, or n times pi. I'm going to erase this stuff, and it's a little bit easier, I think, to show the cosecant and cotangent. Okay? So, if I go back and draw my circle, would you agree that at, whoops, wrong one, at 0, sine is 0, yes? At pi, sine is 0 again. So when I am at 0 or pi, I'll have sine on the bottom become 0, can't do it. But here's the thing, they differ by how much? Pi. So what they did here for this bottom one is said that any n can be any whole number, right? Any integer of n times pi will be a place where sine can't exist. 0 pi is here. 1 pi is here. 2 pi, 3 pi, 4 pi. Wait a minute, let's start going the other way. Negative 1 pi goes backwards this way. I am in the same spots, right? What's the term for that where I end up in the same spot on the unit circle? Where they terminate in the exact same spot. 360 degrees, 0, they are something to each other. 390 and 30 are something. Negative 330 and 30 and 390 are all what kind of angles to each other? What's that? Not reference angles. Reference angles would be the leftovers going back to the x-axis. It's one of the other ones you guys learned. Starts with a C. Corresponding angles. Or not corresponding. coterminal. Sorry, that was coterminal angles. Coterminal angles, remember guys, terminate in the exact same spot. So that's what those would be. And the same thing happens if I am at pi over 2 and 3 pi over 2. They differ by pi still. But so what they say for cosine, cosine's 0 here. And so if I add pi to it, it's also going to be 0 no matter which way I go. And that's why it works that way. That's why we don't have to list every number, because there's multiple numbers. I keep going around and around and around. Any questions? Okay. You guys should also know this. The signs of their trig functions. I only remember the big three, and then from the big three, I know that if I take the reciprocal of a positive number, it is positive. If I take the reciprocal of a negative number, it is negative. I don't have to worry about it. So therefore, how do you guys remember this? How do I know that what quadrant sine, cosine, and tangent are positive in? All students take calculus, or all schools torture children. It doesn't matter how you guys want to remember it, but remember that it follows that C pattern, that it's quadrants 1, 2, 3, 4, right? So we should be able to answer the questions like, what is the sine of cosine of pi over 3? What is the sine of tangent 4? Then, in part C, which quadrant would I be in? So what quad is here? Pi over 3. The way I like to do this is draw myself a little bit of picture and say, where's pi over 3? Should be here, somewhere, right? Not perfect. I'm in quadrant 1. Sine of cosine. I don't even care what the value is. What is the sign? Positive. What about tangent of 4? What quadrant am I in? Wait, what? Oh, man. How far is 4? Is that 4 degrees? Here's the thing, guys. We haven't even talked about degrees for any of these things. We're talking about the number, right? The T number, or the reference number, and all those things. This is 4. How far is this? That's pi. Wait a minute. What's pi? 3.14. So therefore, 4 must be somewhere about here, yeah? So, tangent in that quadrant is? All students take. T stands for the positive one, so it's positive. Of course, going back up to here, if sine's positive, that means cosecant is also positive. Tangent, cotangent, cosine, and secant are all the corresponding reciprocals are positives. For the last problem here, I would make it a little graph and shade. Where is tangent less than 0? Or not tangent, cosine, sorry. Where is cosine less than 0? What quadrants? 2 and 3. Where is sine positive? 1 and 2. Sine's positive here. So, which quadrant would I have to be in? Quadrant 2. This is where both of them are satisfied. Any questions? The last problem, I just cared about what the sign was. Now I want the actual value at the terminal point, right? The actual value of cosine of 2 pi over 3 with its appropriate sign. Cosine of 2 pi over 3. How many pi's over 3's am I moving? 2 of them. One of them's here. One's there. I'm stopping here. using your reference triangles, you would know that you have a reference angle, or reference number of pi over 3. Would you guys agree with that if I made my triangle? That means this is pi over 6. So this has to be 1, 2, square root of 3. Could you tell me the cosine of 2 pi over 3, which is the same as the cosine of pi over 3? Or is it? Cosine in the second quadrant is negative. So we know this is going to be a negative. Do you guys see that cosine of 2 pi over 3 is the same thing as cosine of pi over 3 because of the reference number, reference angle, but I would need to make that answer negative? So you get a negative of, what's the cosine of pi over 3? 1/2. So it's a negative 1/2. Done. Can we do the same thing for tangent of negative pi over 3? Negative pi over 3 goes which direction? Clockwise or counterclockwise? Clockwise. Pi over 3 is here. So negative tangent of a negative pi over 3 is the same thing as, well, this is a reference angle of pi over 3 again. It's not going to fit. Pi over 3. I'll make the triangle all the way over here. This would be pi over 6, 90. So 1, 2, square root of 3, and that should be negative because it's going down in the y direction, right? So what's the tangent of this? Negative square root of 3. You guys seeing that? I just made my reference triangle. Yeah. And sine of 19 pi over 4. I think we have to use what we kind of did in the beginning of class on the board and use the distributive property to break that up. How many times is 4 going to 19? So 4 times, so it'd be 4 pi plus leftovers, 3 pi over 4. And I'm just going to take the sine at that angle. Hey, wait a minute, guys. We should hopefully know the unit circle a little better now, or refreshing. It's a pi over 4. No matter where I move or how many pi's over 4s, potentially the answer is going to have what? A lot of times. Pi over 4, it's going to be square root of 2 over 2, that type of thing. Now, I guess it could end up at a quadrantal, but a lot of times when you don't, you're going to have, all the times you don't end up at a quadrantal, it's going to be square root of 2 over 2. So, if I wanted to go around the circle 4 pi, 1, 2, 3, 4, right? I'm back at 0. And then I have to go how many more? 3 pi over 4s. That's a pi over 4. The y-axis is a pi over 4. And there's your other pi over 4. Where do you stop? You stop right there. Since it's not one of your quadrantals, you know it's going to be a square root of 2 over 2. In that quadrant is sign positive or negative? Positive. Done. Any questions? Homework is on page 426. This is day 1. 13, 17, 33, 43, 47. Have a great day.